Now we're going to look at the monopoly model. So monopoly is going to be one of our four basic market structures that we're covering in this class. Previously, we looked at the perfectly competitive market model, where we had an infinite number of firms who were all producing identical products, and there were no barriers to entry. Now with monopoly, we're on the other extreme. So we have one firm serving an entire market whose product is unique, right? No one else is providing exactly what they're providing. And there are very high or many barriers to entry so that no other firm can enter and compete with our monopolist. So for that reason, we define a monopolist as the sole supplier and price setter of a good on the market, right? Notice that our monopolist is not a price taker, right? They can influence their price and no one is able to compete with them directly. So because they're the only seller in a market, that means that they face the market demand curve rather than having their own specific demand curve like we saw for firms in the perfectly competitive market model. And there are also fewer substitutes for the monopolist product. So we're going to draw their market demand curve as downward sloping, right? And note that it's not perfectly inelastic, right? So we're not saying that there are no substitutes for their product. We're just saying that there are no perfect substitutes. So for our monopoly, right, their demand curve is downward sloping because there might be close substitutes, but not perfect ones. So for example, if we had a monopoly on juice, right? Maybe they don't have anyone who's otherwise producing juice to sell, but their close competitors would be the firms producing soda, right? Or firms bottling water. There are substitutes for soda, but not direct substitutes. That's going to be in contrast to the perfect competition firm, perfectly competitive firm, excuse me, whose demand curve is perfectly elastic because they're facing a market where there are an infinite number of firms producing the same exact thing that they are. So there's an infinite number of perfect substitutes, giving us that perfectly elastic demand curve, right? For the monopolists, they're the only ones producing that given good, right? And so their demand curve is downward sloping. And this unique position of being the sole supplier means that their price is no longer fixed, like we've mentioned just a moment ago. They can set the price of their good. However, the only way that they're able to sell more of a product is by lowering their price, right? That's what this downward demand curve is telling us, that if they want to increase their output, they have to um, decrease their price, right? If they want to increase their output sold, that is. And so an important thing here is that our monopolists, while they're setting their own price, they are still constrained in how high that price can be. And it's going to be constrained by the market demand curve. So our monopolists cannot decide, hey, um, I want to sell my juice at $12 an out, excuse me, $12 a bottle, and I want to sell 10 bottles. No, right? They're gonna have to see what people are willing to pay, and it could be that actually folks are only willing to pay $4. And so the monopolist will charge that $4 price. They can't charge the $12 price, right? Because at $12, right, maybe folks only want to buy one. All right. So that demand curve is still setting that limit on the price that the firm can charge. And that's meaning that we still have consumer sovereignty in a monopoly market, right? Consumers still have the power to choose whether to buy or not. What this means is that our firms cannot price discriminate, right? Because they have to reduce their price to sell more. They can't price discriminate or prevent resale, right? So if I, as a monopolist, was trying to sell my juice for $12 but couldn't, what it might happen is someone purchases my juice at the $4 I can sell it for and resells it for $3, right? That's why in order to sell more, I have to lower my price. This relationship between price and quantity demanded, right? This downward sloping demand curve is what um, defines our monopolists. And it also means that the marginal revenue they face is no longer going to be equal to the price like we see in perfect competition, right? So when we drew that perfectly competitive market model, or excuse me, firm representative firm model, we had that their demand curve equaled their marginal revenue, right? Now with our monopolist, we're going to see a distinct demand curve from their marginal revenue curve, right? And that marginal revenue curve is always going to be below that demand curve, okay? And the reason for this is that when a firm wants to produce more, the price for all of their products falls. So we'll look at some examples. Okay, so here you can see this again in these images on the slide. We have on the left monopolist demand curve shown in blue and the marginal revenue curve below that in purple. And the reason that marginal revenue is always below demand, meaning it's always below the price, is demonstrated by this image on the right. So if initially our firm is producing at P sub 1 and they sell at P sub 1 and produce Q sub 1, they're earning area A plus B in revenue. Okay. If they want to sell Q sub 2, they have to reduce their price to price sub 2. And so that means their revenue shifts and now it's B plus C and they've lost this area A. So in increasing output, reducing their price, they're foregoing some revenue, they've lost some revenue and gained some. Okay. And so that's why marginal revenue is no longer going to be the same as our demand curve, right? We can go through an example where we see this distinction between marginal revenue and the price. So this slide here just walks through what exactly I talked about. In order to increase output, the firm needs to reduce their price, meaning that they are capturing additional revenue C, but they're also losing revenue A. And so we can represent this change in revenue for them as the change in the price over the change in quantity, right? That how much does the price fall and how much does quantity increase times the amount sold. It's going to give us the fall in revenue for area A. And the new revenue is just the price P times the amount sold. And so we can combine this into an equation for marginal revenue, right? Marginal revenue is the area of B plus C, so the amount sold times the new price. And then adding to that what's lost from area A, so that negative change in price over quantity times the amount, right, sold. For this reason, when for the fact, so because we can represent marginal revenue with this equation, we can actually show a very useful relationship between demand and marginal revenue when demand is linear, right? But this is only for when demand is linear. And for our class, we're always going to be working with linear demand curves, all right? When we have a linear demand curve, it means that our slope of our curve is constant, right? That's what defines our linear curve. And so we can notice that our marginal revenue equation has a similar format, for lack of a better word, to our inverse demand equation, right? So our inverse demand equation is price equal to some constant A minus the slope times quantity. And our marginal revenue equation is price plus some negative slope times quantity. All right, so we have this same negative BQ going on. So for in both equations. So what we can do is notice that our demand curve is defined for price, right, when it's in its inverse demand equation. And so we can substitute for the price in our marginal revenue equation. So doing so gives us marginal revenue equal to the price, which is A minus B times Q. That's this parenthetical here, plus the change in price over the change in quantity times quantity. And change in price over change in quantity, because we have linear curves, are both going to be that slope of our demand curve. So we're going to have negative B for both. And we'll have marginal revenue equal to A minus B times Q plus minus B times Q. So what we can do is go ahead and combine like terms, and that gives us this equation of marginal revenue is equal to A minus 2B times Q. So we're sort of using the same inputs that we use to define demand to define marginal revenue. And so what that means is that our marginal revenue curve is always going to be twice the slope of our demand curve, right? You can see that the only difference between these two equations is that -2, or the 2 in the marginal revenue equation. Otherwise, it's the same as our inverse demand equation. Okay. Before we move on, let me give you an example of our marginal revenue falling more quickly than demand for our monopolist. So let's say that our monopolist goes from pricing seats. Let's say initially they were selling movie tickets, and they were selling these movie tickets at $5 per ticket, and they were able to sell 500. Their total revenue, right, from that is going to be P1 times Q1, which gives us 5 times 50, which is going to give us $250 for total revenue. And let's say that to increase their output, they drop their ticket price by 50 cents in order to increase their sales by 50 tickets. Okay, they had empty seats that they wanted to fill. And so their new total revenue is going to be price times price sub 2 times quantity sub 2. So that will be $4.50 times 500. Oh, I did this incorrectly. So our initial one should have been 2,500, excuse me. I dropped the 0. We'll have $4.50 times 550. That's going to give us $2,475. So when they price at $5 and sell 500 tickets, they get $2,500 in revenue. And when they price at $4.50 and sell 50 more tickets, their total revenue actually falls. So here's where we're seeing that our marginal revenue is falling faster than demand. And so if we find marginal revenue, right, it's going to be the difference between total revenue 2 and total revenue 1. So we'll have 2,475 minus 2,500, and that's going to be negative 25, right? So you can see that marginal revenue here is less than that price. Okay, all right. Now we can go ahead and continue on. And let's do an example where we find the firm's marginal revenue. So remember, right, if firm's inverse demand equation is price equal to A minus B times Q, we can write our given demand curve in that same format by solving for the price. So we'll have quantity equal to 200 minus the price. We're going to add the price to both sides. So we'll have price plus quantity equal to 200. Then we'll subtract the Q. So of price equal to 200 minus quantity. So here, 200 is our A term. Our B term is this 1 that's implicitly there, right? So B is -1. So there we go, this is B. And then we have quantity. And in our previous slide, we talked about that marginal revenue when we have a linear demand equation is equal to A minus 2 times B times Q. So what we're going to do is write out our marginal revenue equation using this relationship, right, for our given demand equation. So marginal revenue is equal to A, which we found to be 200, minus 2 times B, which is 1, times quantity. So that means our marginal revenue is 200 minus 2 times Q. That's going to be our option C here, and that is correct. Okay. Let's do another example. So we have a new demand curve, quantity equal to 100 minus 2 times the price, right? Remember our inverse demand equation is price equal to A minus B times Q. So let's find that by solving this given demand equation for price. So we're going to add 2 times P to both sides. That gives us 2P plus Q equal 100. Then we'll subtract Q from both sides. That gives us 2 times the price equal to 100 minus quantity. And then we divide by 2. And that gives us price equal to 50 minus quantity over 2. Or we could say quantity times minus 1/2 times Q. Okay, same thing. So our A here is that 50. Our B is that 1/2. And so if we use that same relationship we used before, marginal revenue equal to A minus 2 times B times Q. Since we have a linear demand equation, we can do that. And now that we have our inverse demand equation, we can very easily find marginal revenue. So marginal revenue equals A, which is 50, minus 2 times B, which is 1/2, times quantity. So simplifying, we get marginal revenue equal to 50 minus 2 times 1/2. That leaves us with 1, right? 2 goes into itself once. So we are left with marginal revenue of 50 minus Q. The next part of the question asks us what the firm's marginal revenue is when quantity equals 10. So we're just going to substitute 10 for our quantity term, and we'll get that marginal revenue is equal to 40. All right, so that C is our answer again, and we are correct. We'll stop our, will we stop our video here? Yeah, let's go ahead and stop our video here. We've gotten the basics of our, monopoly model, and we're going to look at what determines for the monopolist when they are profit maximizing.